and I'll do the attendance in a bit. Solving problems that involve rates. Okay, so we're going to write that part down. When dealing with proportions, okay, you just write out your ratio, including words, including units or words, like sometimes it's cans or whatever. Make sure that units line up. Example, if cans are in the numerator, if cans are in the numerator in the left, make sure it is also the numerator on the right. So example, if you need 2 cans, to paint an area that's 315 square feet, right? Then with 5 cans, you would be able to paint X number of square feet, right? So just make sure cans line up with the top, and then obviously there will always be one unknown, and that will be matching the units on the other side of this, okay? So just be careful there. So let's do some examples. It costs $900 to fly 8,000 kilometers. How much will it cost to fly 350 miles? Question mark. So copy that down and actually give that a try. See if you can solve that on scrap paper. I think he's trying to say that you should flip it, and you can, but if you're, I think there's an announcement, hold on. In this case, it won't matter, okay? Like I'll show you why, okay? You will get the same answer. The problem here is that 350 miles does not match with kilometers. So what I will do is I will convert this on the side, right? We'll convert to kilometers. So we have 350 miles. We know that, there's a relationship between miles and kilometers, and we know that we want the miles down here because that will cancel out here. So 1 mile is 1.609 kilometers. Okay, so the miles cancel out. We come up with that. So we go 350 times 1.609, and you get 563.15 kilometers. Okay, so you've now converted 350 to kilometers. That is what we're going to put here, and we're going to put it in the denominator because kilometers are in the denominator to begin with. So that's 563.15 kilometers. Okay. Oh, that's too bad. Hopefully today it won't. Charles, hopefully today the recording will go through, and if you missed anything, it'll be there. Uh, so this is our dollar amount up here. So it's technically X number of dollars, right? And when it's a proportion like this, you cross multiply and you divide by what's left over. I always start on the side where my unknown is, obviously picking the number. So if you're in the denominator, you're going to multiply up and divide down. But you always multiply first and divide second. Okay, so X is going to be 563.15 times 900 divided by 8,000. Okay, and so we figure out what that is. And that's 63.35. And what are we in? What units? Well, we are in dollars, right? Because you're finding the top number and it matches the dollar amount across. Okay, so okay. It, yeah, yeah, you should get the same. As long as you match your units, you're fine. No, that's okay. That was pretty funny, actually. Okay, not probably not for you, but listening to that voice was interesting, to say the least. Okay, so we answered the question, um, and so we have that figured out. So let's keep going. So there's some conversion here, and we're using proportional reasoning. Proportional reasoning, always think back to cross multiplying and dividing. Okay. Anyways.
Excuse the interruption, please. The English department meeting is now in the library. The English department meeting is in the library this time. Thank you.
A squirrel can run, right? A squirrel can run 32 meters in 65 seconds, comma, while a pig can run 295 meters in 1 minute. A, who is faster? And B, how long in minutes, comma, would it take for the squirrel to run 152 meters? So two-part question there. So write that down. I hope that at this point you're done writing this down. So let's answer A first. Who is faster? When it's asking which one is better, who's faster, and whatnot, I would convert to a unit rate. Convert to unit rate. And in this example, what we're going to do here is we're going to convert both meters per second, right? So meters in 1 second. That's what I'm going to do. And so the first one, right, the squirrel, runs 32 meters in 65 seconds. It already has the units that I'm after, so no conversion needed. Once you're done converting, then you turn it into a unit rate. So you would divide both of them by 65, right? Whatever the denominator is. And that leaves you with just second, right? 1 second to be precise, and 32 divided by 65 on the top, which is 0.49 meters per second. So that's the squirrel. And the pig, we will find that it's 295 meters in 1 minute, which is 60 seconds, right? No big deal there. We divide both of them by 60. And so you get 1 second here. And it's 295 divided by 60, which is 4.92. 4.92 meters per second here. So obviously, in this case, pig is fast. This is faster. Pig is faster. By how much? Let's answer that. By, and somewhere on this paper you would do the math, right? So you go 4.92 minus 0.49, and you get 4.43 meters per second, right? By 4.43 meters per second. I don't know if this is accurate. I just made it up. So I might be off there. But anyways, let's answer B here. B says, how long in minutes would it take for the squirrel to run 152 meters? Okay. So we go back to squirrel. You can use the unit rate because technically the unit rate and the rate are saying the exact same thing. However, when you converted this to a unit rate, you lost a few decimals, right? Because you rounded here. So I'm going to use the exact same one that I started with, knowing that 32 meters in 65 seconds, right? That is true. That's what the squirrel can do, right? 32 meters in 65 seconds. And so right now they're asking you how long would it take to run 152 meters. So I will put the 152 meters there. And this will be my unknown, the time, right? I'm supposed to give the time in minutes, but I'm going to get there in a bit, okay? So x would be, you start over on this side, you cross multiply down, you divide up. So it's 152 times 65 divided by 32. Sorry, I'm running out of runway there. 152 times 65 divided by 32. That is 308.75, and we are in seconds, right? 308.75 seconds. We're going to go ahead and convert this now. And I'm going to use this little box here on the side. 308.75 seconds times, we know that 1 minute has 60 seconds. It's just to be consistent with our conversion, how we're doing conversions, right? And that is 308.75 divided by 60. That is 5.14. Oh, sorry, 0.15, that is minutes. Yes, I know what you're thinking. That could be, you could have said 5 minutes and then seconds, right? Absolutely. You can convert the 0.15 minutes to seconds by just multiplying that by 60, right? You can find out what the 0.15 of a minute would be in seconds if the question asked you to. So why don't we 5 minutes? Yes.
How will you say that the squirrel get tired and it takes only 5 or 15 minutes?
That's an assumption that we're making. Okay. 5 minutes and 9 seconds if you round it. Okay, you multiply the 0.15. Actually, the 0.1458, I took all the decimals and I multiply that by 60 to get 5 minutes and 9 seconds. Now, of course, right, any question with rates, as Mark was pointing out, is assuming a consistent change, like that rate does not change. Okay, one could argue that that's the average speed, that a squirrel could be faster or slower at times, but on average, that is the speed, right? Same when you're going 100 kilometers an hour on the highway, you're actually not going exactly 100, right? Depending on where the wind is coming from. Sometimes you're going a little slower because the wind is going right against you, and then you have to speed up again. Like if you're going on cruise control, right? Like you're constantly fluctuating around the 100-kilometer mark, right? So that we're assuming that it's a consistent rate there. Okay, so let's pause there for a bit. We're going to continue with our notes. And this is kind of going to go into, we're going to already start 8.3 as well. So I wonder if I should just go ahead and, yes, I'm going to give you the homework here. Can you write that down here? I'm going to use a different color so it sticks out. Homework would be page 466. And we're going to go questions 1, 2, 1 to 9. And so they shouldn't take you that long, right? There's just a bunch of questions like these that involve rates, and basically they ask you if this rate is true, what would it be for this scenario, right? So the rate gives you two different units, and they're gonna give you one of the units and ask for the other. And so you use cross multiplying and dividing. And you might have to do some conversions as well, like we've done here, right? So just watch, just read carefully and follow through there. So now I'm gonna go on to 8.3, which is scale factors or scale drawings. Okay.